All right, for the next problem, we have in the numerator we have two fractions, which makes this a multiple fraction. No one wants to add those two things together, right? So we're going to use our method too. But the denominator only has whole numbers. Well, you have to treat everybody as a fraction initially, in order, because if you don't, then some people forget to multiply both the numerator and the denominator by the LCD, which we're going to find here. So the LCD between all denominators, and the denominators I'm looking at are x and y and 1 and 1. Not the x and the 3, those are numerators in the denominator. So we have x and y, and they both are raised to the 1 power. So now I'm going to multiply every single fraction in the numerator and the denominator by the LCD xy. Please don't be lazy, write them all down. So my big red fraction bar is what allows me to do that. So I'm going to keep my big red fraction bar here. In the first numerator, the x and the x divide out nicely, and you're just left with 2y. On the second fraction, the y and the y divide out nicely, and you're just left with 1x. Or you could probably just write x. On this next one, we have xy times x over 1. Because it's over 1, nothing's really going to divide out here, but you needed to make sure that you treated the numerator and the denominator the same. So you did need to multiply the LCD by both of those. And it gets me x squared plus y. And on the other one, I hit 3xy. Now I'm going to try to see if I can factor anything. Nothing factors in the numerator. And in the denominator, I can factor an xy out, which leaves me with x plus 3. Nothing divides out nicely, so this is my answer, or this one's my answer. They're both the same, just written slightly different. Nothing reduced, so either one will work. On this next problem, I'm looking for the LCD. Don't forget to turn your h into an h over 1. So the LCD, I'm looking at all denominators. I have to have a factor of x, 3 plus h. I have to have a factor of the 3, and 1, you don't really need to include that. So that's going to be my LCD, 3 times 3 plus h. Now I have to write that on every single numerator. So I'm going to go ahead and write 3 plus h and times a 3. It doesn't really matter what order you put them in, you just have to have them on all of them. On the first fraction in the numerator, I'm going to continue to write my big red fraction bar in red. On the first fraction in the numerator, it looks like the 3 plus h divides out, and I'm left with 3 times 5 plus h. I will finish that up in a minute, but I'm not going to worry about it right now. I don't want to make any mistakes. Then there's a minus. On the second fraction, the 3 divides out, and I'm left with 5 times 3 plus h. Again, I'm not going to distribute those out until later because I don't want to forget that the negative is attached there. In the denominator, nothing divides out with 1, so that just gets me 3h times 3 plus h. So I still have some distributing to do to make this a little bit neater. Don't forget when you just distribute the 5, it's a negative 5 with it, so that's negative 15 minus 5h. And I combine like terms. The 15 minus 15 adds to 0, and I am just left with 3h minus 3h minus 5h, which is negative 2h. And it looks like one of the copies of h in the numerator and the denominator divide out nicely, and my final answer should be negative 2 over 3 times 3 plus h. On this next problem, don't forget to divide the 3 by 1 to make all of the terms a fraction. Then we're going to be looking for the LCD. The LCD between 7x minus 1 and 1, 7x minus 1 and 1, is just 7x minus 1. is raised to the invisible 1 power, so I only have 1 copy of those. Then I'm going to multiply every single numerator by 7x minus 1. On the first fraction, the 7x minus 1 divides out, and I am just left with 3. On the second fraction, nothing divides out, and I'm left with minus 3 times 7x minus 1. Don't try to do that in your head. You might forget to bring the minus down and distribute the minus, so try to do that on another step. In the denominator, the first fraction, the 7x minus 1 divides out, and you're just left with 3. Then we have a plus. Nothing divides out on the last fraction, 3 times 7x minus 1. We're going to distribute and combine like terms if we can. 3 minus 21x plus 3 over 3 plus 21x minus 3. In the numerator, when we combine like terms, we get 6 minus 21x. And in the denominator, the 3's divide out, and I'm just left with 21x. It looks like I can factor the numerator that has a GCF of 3. 2 minus 7x. And the 3 and the 21 can divide out to 7 in the denominator. So my final answer is 2 minus 7x over 7x. Can you divide the 7x and the 7x? No, because the numerator 7x is within its own binomial, so that little minus sign basically glues those two terms together in the binomial in a parenthesis. So don't try to cancel the 7x with a 7x. That is our final answer, and we are done.